New product time. New.
Okay, first up is you.
Yeah, first up is me.
You got some to show off.
Yeah, so the Menta now has a nice label on it, and it's available as a separate item. It's only for some of the folks that we're experimenting with for retail. AC Gears in New York City has these, so we're working with them. Make is the other one that has retail versions of our stuff, and you'll see some announcements soon about that, I hope. But anyways, we can go to the overhead, and you can see it's just a little label that we designed. We like it.
Bleep, bleep. Yeah, we're getting these very nice labels made in New Jersey by our favorite label maker.
Yep.
Printing company.
Yep.
So
there it is.
Built-in barcode.
Yeah, and these can be shrink wrapped for retailers specifically for them. And
so the nice thing about
the
nice thing about the Menta is that all the parts can fit in the tin. I mean, this is empty, but all the parts can fit in the tin, and then you put the label on it, and then you're done.
All right. Next up. We branched off into the wonderful world of small tools.
Well, we've actually had a lot of hand tools already.
Yeah.
But the last tools that we put in, they had pentalobe screws in them, and somebody was like, "Oh, are those for iPhones?" And we're like, "Well, let's try." And we're like, "Oh, wait, they're not. They're actually like pentalobes for something different." I think they were for old like MacBooks. So we decided to get in a set of tools that will work with iPhones, both new and old, as well as MacBook Airs, and then the new MacBooks as well.
Yeah.
They also use this new pentalobe. So I have these tools, and they're really nice. We actually have a box of all sorts of tools. I can bring it out and show it off eventually.
Yeah.
Maybe at the end.
So these are the different ends.
But we tried a whole bunch of different tools, and we like these. These are they have knurled grips. They're a hardened tool steel. You can use them over and over again. They're pro grade, and they've got a nice balance at the end. They have a rotating cap, so you can hold them straight and twist them. But we found that they're so even if you're dealing with a rusted screw, they can still get it out.
Yeah,
but they're perfect for.
Real quick, I have a fast demo, and this is kind of on. It's part of a bigger project that we're doing. So this is my iPhone, and I didn't like the black backing because it has the Apple logo. I know there's a little bit of thing. Anyways, depending on which iPhone you have, it'll either have the pentalobe or the Phillips. And once you take the two screws out, you can slide the backing off. And once you take the backing off, you can see it's iPhone. Look at the back of it. You wouldn't want to walk around like that. We have these clear cases we're going to be selling soon. And one of the reasons I like these clear cases is because I want to put this RFID tag inside of there. I don't want to put it on the outside because it'll come off. So that'll be a project. I didn't stick it on there. But then we have some other hacks and mods, and also people like to repair these. There's millions of them out there, so we'll have some cool stuff. And we also have some backings that you'll be able to laser etch and do some weird stuff. So, anyways, this is the backing of mine. This is a clear backing, and we'll have these, and you can get these screws now. And we have some old Macs here and some new Macs, and we have to repair them and do some weird stuff with them once in a while. So we got these great tools, and as Lamore said, these things spin, and you can open them up pretty fast. So we'll show you how to RFID NFC an iPhone, since Apple's probably never going to have that. Yeah. Anyways. Okay.
Good if you like. I know in Boston they have an RFID system for the train.
Yeah.
So you could put your pass inside your phone.
Yeah.
And then you can hold it up when necessary because it's a clear back. But then when because it's a monthly pass. But then when you're going through the turnstile, you can put your phone down to go through with your Charlie card.
Okay.
Okay, cool.
Next up, we also, we added screws because we were looking around online, and they were like $6 or $7 for 2 screws. So we have a great price. So we're selling them just for a couple bucks because they're hard to get. But
so these are replacement screws for iPhones.
Yeah.
Actually any 4 model. We have them both the original pentalobe, or you can replace them with the Philips.
Yeah, I like using the Philips. Okay.
But some people want to have it be like the same. They don't want it to make
Yeah.
it. They don't want anyone to know that maybe they lost a screw. Or they want them to match or something.
Yeah.
I don't know.
Okay. Next up, we have these great waterproof cases that we just released. And for the people who want to know, can an Arduino fit in it? Yes, it can.
Yeah, I have an Arduino.
We have an Arduino already, so let's go to the overhead.
Yeah. So this is just the case, and I like this case because there's a black gasket. You can see this gasket. So it's water. It's actually not waterproof technically because you can't dunk it underwater, but it is weather resistant, so you can put it outside and it'll be fine. It's just not it's not graded for like being dunked underwater for more than like 5 minutes. And there's mounting holes on the back. There's some brass inserts on the inside. We have measurements that Becky made that are really nice. We thought it was cool because you can fit like an Arduino and a shield in it, and then there's a clear top. And then there's these big plastic screws that are actually they're captive, so you can easily screw them in. You can screw them by hand even to get them started. And so it's a clear box, so it's protected, but you can still see any indicator lights. Well, I don't like boxes that are not clear because if you have like an LCD or display inside, you want to be able to see what's going on inside.
So I'm going to show a couple of photos. We have here's the Arduino inside. Here's the back. Becky did a bunch of good measurements. You can see that
you can fit a Proto exactly, but you can't fit a half-side breadboard.
Yeah, and then we have a larger one. This is
it's really big.
A lot bigger.
It's so big I can't really show it on the overhead, but it's really big. So we decided to carry like a really massive one for really big projects as well.
Yeah. And like the Arduino enclosure would fit inside that one.
Yeah, you can put this box inside that box.
Full-size breadboard fits. So you can.
So good for bigger projects when you need a lot of space. You want to like mount buttons and stuff to it.
Next up, we're going to just go through these quick too. We have a bunch of colors of these LED wire lights. They're actually very pretty. So here's a bunch of photos, and I'll go through these before I go to the overhead. So you can see all different colors. They wrap around things really nicely. Becky did some photos of things that you can do with the stuff, and we'll show a video in a second. But let's go to the overhead.
Okay.
So you can show.
Yeah, turn off the lights. So this is the wire lights, and I'll show them in detail. But I want these batteries in. So it uses 2 coin cells, and these are pretty common CR2032 coin cells. And the holder is translucent, so you can kind of hide it very easily. And then there's an on switch, and so there's these really bright LEDs. And the neat thing about them is the LEDs they're bonded onto a wire. So they're flexible and small, and so you can like do costuming or a project where you want to add lighting but have it be very subtle. Like when it's actually attached, you can barely see the wire itself. Like there's this very thin wire that connects them.
Yeah.
And it's magnet wire, so it's even waterproof.
Super bright for a coin cell too. I mean, those are pretty
nice. They're actually. I said like make sure they're at least 1,000 millicandela LED, and they said okay. So when they made these, they made sure they were pretty bright, and so we have them in a bunch of different colors. And to solder them, you have to scratch off the coating from the silver wire. Or you can just attach. You can just cut the wire off here where they attach the battery holder.
And we have a video for Becky. That means we can have another drink.
Drink break.
Okay, here we go.
At Adafruit, we now have these really neat strands of LEDs on a super flexible wire. And they're powered by 2 coin cell batteries, which means you can put them basically anywhere. We have them in 5 colors, including warm and cool white. And inside the battery holder, the batteries lay side by side, so it has a super low profile and even includes its own on-off switch. Here are some of the things I tried with these LED strands. You can coil them up and put them inside a balloon, and I even left the battery holder outside so I could turn it on and off. I think this will look really nice at a wedding in a big bunch of illuminated balloons. They're perfect for wearable applications because the wire is really stiff yet flexible, so it holds its shape when you wrap it around things like this headband. And I couldn't resist adding them to Olive's collar to see her glow at night on our walks. If you want to show us your LED project, come to our weekly show and tell Saturday nights on Google Plus at 9:30 Eastern Time. They're also archived to YouTube, so you can catch all of them in the playlist right here and learn how to get on the show and tell yourself. See you next time. Don't forget to subscribe.
All right.
Okay.
Another great video from Becky.
Thanks, Becky.
Okay, and moving on, this is kind of there's 2 stars of the show, I would say, besides you and Kate. There's these, and Becky tuning in virtually.
Yeah.
So 3. But this is the bicolor LED matrix. So I'm kind of excited about this because
this is the third matrix. So we had the mini 8x8s, we had the 7 segments, and then finally, because the chip can handle up to 8x16 LEDs, I was like, well, this is a perfect match for our bicolor matrix that we carry, which is a really beautiful matrix with these lovely square pixels, super bright, and just like a perfect little display. But the problem with the display is, of course, it needs 24 pins to control it, and that's like a real pain in the ass. So what was nice is that by using this chip, you can control the entire matrix. You can actually control 8 of these at a time on one I2C bus using very basic commands. And so I have a little demo program running.
All right, let's go to the overhead.
And we can show it on the overhead.
Yeah.
So I have it scrolling some text. It's flashing because it's the refresh rate. It's not actually flashing in real life. But you can see it's got these nice big pixels, and it can do green, orange, red, and then the orange color is what happens when you light up the red and the green at the same time. So some people are like, well, wait, it's bicolor, but then your photo has 3 colors. That's because when you turn the red and green on, it turns like this orangish yellow color. So yeah, it's really easy to use. The nice thing is that, like, you know, you just basically say draw pixel or draw word, you know, text, and the text gets drawn. You can draw bitmaps and stuff. The thing about the display that you can't do is you can't mix the colors. So what I mean by that is you can turn on red and green, but you can't do any PWM mixing. Like, you can't say, oh, I want like a reddish orange or like a green that's slightly yellow tinted, because the board can't do PWM per pixel or even per color. It can only do it for the entire display at once. You can dim the entire display, or you can you know, basically turn off or on and off certain LEDs. So I still think that, like, despite that, it's still really handy. For something a display like this, maybe 3 colors is plenty for you. And again, it's really easy to use. So I think this is like basically this solution to, because people are asking, how do I use this display? Because it needs 24 pins.
Couple quick questions. Is a 3-color version possible or in the works? Technically, this is 3 colors.
If you want to use a tricolor board, I actually did spec out getting matrices that are tricolor. The deal with the tricolor displays is now you're talking like just a massive number of pins, and the only really fun thing you can do with them anyways is you want to have color mixing. If you have 3 colors, you can do all colors, because you can mix them together to make, you know, everything from white to teal to, you know, yellow to green to blue to pink. So if you're going to do that, I looked into it and I was like, you know what? It's actually so expensive to make a backpack for that, because you have to have it. There has to be PWM per pixel. That you're better off actually just using the RGB matrix displays we have in the store that are 16 by 24. They're quite big, but you know, you can get a 16 by 32, 512 LED, a tricolor LED display for $80, and it has all the driver circuitry on the back. And you can use it with an Arduino fairly easily. You know, honestly, like, that's kind of what I ended up going towards, because for the price and everything, it was such a good deal just to use one of those panel displays. We're
going to keep moving because we were running out of time, but we got another awesome new product. This, I've not seen anywhere. This is awesome. This is a current sensor.
This is a current sensor, and this is what I think of as like a really good current sensor too. So we have a current sensing panel mount meter, and it's really handy because it has a little LED display, and it'll tell you like how many amps you're drawing. But one thing about it is it's not very precise. It only does like 10 milliamps resolution. And the second thing about it is it's only good for low side current sensing. So, oh wait, where's my marker?
Oh, do you need a...
I need a non-permanent marker unless you want me to use this. Here, I'll use this.
No, I'll grab it. But you
so the problem with...
You want to write with that? Okay.
The problem with most current sensing, the cheap way to do current sensing, is like you have your power supply here, and then you have your project here, which we're going to call the load, and then it's connected to ground. So the problem is for the most part, if you want to measure your project and you want to measure the amount of current going through here, the only really easy way to do that is to put a resistor between the load and ground. So this is like a 0.1 ohm resistor, and then you measure the voltage here. And then if you multiply the voltage, knowing the resistance and you know the voltage, that means V equals IR. You know what the current is. The problem is that a lot of times if you have a load and like let's say this load is connected to some other thing that can be connected to ground, or there's some sensors or something connected here that somehow connect to ground, it can start like not working so well. For example, the Tweetawatt project one of the things that we had to do with the XB is the reason that we have to use an XB for wireless is because the ground in the kilowatt is not really ground because it uses this technique. And so if you connect it to another project externally to measure, the grounds get connected, and then like the kilowatt starts freaking out because ground is not a true ground. It's this fake ground because there's a little bit of a voltage drop here. So another, what's preferable to do when you want to measure is connect your load directly to ground again, and then you put your resistor up here, and then this goes from the positive voltage. You measure your voltage here, and then it's the same 0.1 ohm resistor, and you can measure what the current is. And this is called high side because you're at the top side, the positive voltage side, instead of the low side, which is down by ground. So this is a lot better because first off, your grounds aren't moving around, which is better for everybody. Nobody likes it when their ground reference is moving, depending on how much current. But the problem is that this is a lot harder to do because let's say you're powering something off of 12 volts. Well, that means like you have to have an op amp or something that can measure, or if you're measuring off of like a microcontroller or something, it has to measure something of 12 volts. So you have to like measure this difference voltage, and it might be higher than your power voltage. You have to have an op amp that's rail to rail, and then you have to do a lot of like manipulation. It's a lot harder when you're referencing a power supply because you're taking a difference because you don't necessarily know what this voltage is. This also might move up and down. It's a little bit tougher because you want to get this differential voltage here. So basically that's where this sensor board comes in, because it's designed specifically for high side current sensing. So there's a connector here, and you put this board between your high side and your load, and it's digital, so you connect to it with I2C, and it has a load resistor built in, this big chunk here, which is a 0.1 ohm, 2 watt surface mount resistor. And so your load can be referenced to ground, and everybody's happy over here. It can measure up to 26 volts DC, so even if you're a microcontroller system, you're trying to measure motor voltage, and so the motor voltage is much higher than 5 volts, you can still measure it without having to worry about getting an op amp that can handle this high voltage and then moving it up and down and manipulating it. And it's very precise. It's got 1% precision. And the other really cool thing is because it's connected to the high side, it will also report back what the voltage is. So you'll know both what the system voltage is and the current. So that can help you, especially if you're doing like stuff with solar panels, instead of using 2 multimeters, one to measure the panel voltage and another one to measure the panel current, which is what I did when I was doing a lot
I remember we had to do that when we were testing our solar stuff.
Yeah, so you have a lot of multimeters involved. It's kind of a pain in the ass. This will actually do everything all at once. It'll report it to you very, very quickly. So I really like it. It's really easy to use. You can use it with 3 or 5 volt systems. Like I saw this on like a mailing list, and I was like, that is a really nice chip. I'd really like that, because if I'm ever going to do stuff with current sensing, I'd rather use this than grab a multimeter and then you're watching the multimeter and you're trying to like track what's the maximum current, and like you want to log the data. Now it's really hard, and now you have to get like an Arduino involved. And I did, but it was like there's a lot of like annoying op amp wiring involved, whereas I could have just like spliced a wire, shoved this in, connected up to the 2 I2C pins, and like you're done. It's super nice.
And you're selling these for like $9.95?
Oh, I don't remember what the price is.
It's $9.95.
Okay, yeah, it could be. And I will check the webpage.
And it's on sale in the store.
Is on sale? Yeah, it's like 10% off.
Yeah.
So if you ever have a project where you have to like measure your current draw, and you want to also track your voltage, this is awesome. This chip is great. It'll kind of solve all your problems. It only does DC voltage, so it's not good for mains current. You can't put this into your wall. It's not good for 120 volts.
How is this different than Dave's microcurrent, by the way?
The microcurrent is an op-amp based solution. It doesn't give you a digital readout, and also doesn't give you the voltage. It only gives you an analog amplification, basically, so you can still use your multimeter.
Okay.
That's a multimeter assistant.
All right. That's the end of new products. Whew, you got through it.